I want to look at an uglier example here, one that will require a bit of calculator work. So we take a look at number 12. When I go to find my modulus, it's no different than the previous ones. I do need a square root there, and it'll be the square root of negative 11 squared and a negative 8 squared. So not too crazy here. The opposite of the square root of 11 squared is just 11. And negative 8 squared will be 64. So we wind up with a 64 plus 11. That is 75. And we can break that 75 up, no problem. That's 25 times 3. So our modulus will be 5 root 3. So that one's not the issue. The issue is going to be with our angle. You can try as hard as you want. Theta, again, is tan inverse of y over x. You will not be able to find negative 8 over negative root 11 on a unit circle. So this is where we want to be careful. Both the real and imaginary parts are negative, so we want a quadrant 3 angle. Keep in mind, tangent is going to give us, tangent inverse is going to give us an angle between negative 90 and positive 90. So tangent inverse is going to give us back an angle either in the first or the fourth quadrant. So we're going to need to do a bit of work, but we'll go ahead and just jump over to the calculator real quick. I'm going to clear history and make sure we are in degrees. Yep, good to go. I'm going to go ahead and work with degrees because I'm a bit more comfortable playing around with that medium. With radians, it's really nice when you know, like, hey, pi over 3, pi over 6, something like that. We know right now we're going to get a really ugly number here. So let's go ahead and play in degrees where we're a bit more comfortable, a bit more confident. And in my numerator, I had 8. And in my denominator, I had a root 11. Keep in mind, negative divided by a negative is positive, so I'm going to just omit those negative signs. So this is going to give us 67.48 degrees. So that is a first quadrant angle. So keep in mind, that's giving us something up here, something in the first quadrant. But I wanted an angle in the third quadrant. So there is an angle in the third quadrant that has that same tangent value. In order to get it, all we need to do is add 180 degrees to the angle that was given to us by the calculator. So the angle we actually want is 247 point, we'll go ahead and round to the nearest hundredth there, 247.5. Again, the reason that I needed to do that is I wanted a quadrant 3 angle, but the calculator gave me a quadrant 1 angle. So in order to go from that first quadrant down to an equivalent angle in the third quadrant, one where tangent gave us the same ratio, we needed to add the 180. So be careful when you end up using your calculator because it is easy to overlook things like that. Putting this all together, same as we've been doing. 5, let's go ahead and call it C. 5 root 3, that's our modulus, and we will still have a cosine of 247.5 and an I sine of 247.5. Super difficult to see, so let's bump it all down a bit. Once again, that 5 root 3 is our modulus, coming from that Pythagorean theorem, and then that 247.5, that is the argument coming from the calculator. Thanks, calculator. Actually graphing this thing, it's not going to be super accurate. Again, keep in mind, quadrant 3 angle, 247.5. So it's not going to be quite 270. It is going to be more than 180. So we are in that third quadrant. We could dial it in a bit closer than that. And then 5 root 3, getting a more accurate, well, at least easier to visualize radius there, 8.6, roughly 8.7. Each one of my tick marks counts for 4. So I'm going to go 2 and a little bit. So again, not super accurate here, just getting a rough idea of where that point is going to be. Yeah, looks good. Now it looks good. Success.